Welcome to the MMEC course in Organic Chemistry. My name is Mostafa Mahgoub, the founder of this educational center. In this course, we'll be talking about concepts, nomenclature, and reactions of organic chemistry. So without further ado, let us dive in. Organic chemistry revolves around the studying of one particularly important element, which is, yes, carbon. Carbon is really important. The way it bonds to itself and other elements, making tens of millions of molecules, is really important in making life as we know it. And also it is really important since we discovered how to synthesize organic molecules from inorganic elements. It's really important in the pharmaceutical industry and making fertilizers and so many other things. So in order to be on the same page with scientists in organic chemistry, you have to know the nomenclature of organic chemistry. Nomenclature is a way of describing the name of describing the molecule through a long name which undergoes certain rules. This rules called the IUPAC rules. IUPAC nomenclature. IUPAC is for International Union of Pure and Applied Chemistry. It has made so many rules that control the nomenclature of organic chemistry in order to make it possible to know the shape of the molecule from its name and the name of the molecule from its shape. So, for example, we have this constitutional name. We have 1, 2, 3, 4, 5 carbons. Okay, how do we name this molecule? We name it according to these names. We have meth, eth, pro, but, pent, hex, hept, oct, non, dec. So, meth is molecules that contains 1 carbon, eth 2 carbons, pro 3 carbons, and but for 4 carbons, and etc. The other. So we have here 1, 2, 3, 4, 5 carbons. So this 5 carbons, this is pent. This is called pent. And it's really important to know the geometrical shape of the molecule. So this molecule's geometrical shape is like this. I know this might be ugly and really unnecessary, and that's why organic chemists and scientists has summarized this shape to this. This is simpler, and because it's logically, carbons are attached to 4 other elements. And here, the edge of this carbon, it contains 3 hydrogens and attached to another carbon. This carbon attached to 2 carbons and 2 hydrogens. So this is why this carbon is attached to 4, according to the rule, octet rule. I talked about this extensively in the general chemistry. I suggest you check out the other course when we talked about hybridization, sp3, sp2, sp, hybridized orbitals, and all of these things in general chemistry. I'm not going to talk about it here because it will take a lot of time. So we have summarized this shape to this. This is more practical because we will deal with very large molecules like cholesterol or other molecules. It's really huge, and it's really difficult to write it in this terrible, ugly shape. But when you look at this shape, you know that this is what it actually looks like. And we will notice on this shape that we have wedges and dashes. Wedges means that this hydrogen coming towards us, and dashes means that hydrogen goes into the plane of this page. So, for example, this hydrogen, if this is the carbon that is attached to it, it's coming toward us, and this hydrogen is going further away from us. So, let's get back to the nomenclature. We have the nomenclature of this molecule, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So it's pent. Okay. So we have single bonds. Single bonds end with the suffix ane. Pentane. So this molecule named pentane. Regarding this ane, it's with a single bond. But what about if we have double bonds in this area or in any other area? We will have ene. And if we have triple bonds, 3 bonds, we will have ine. So ane for single bonded hydrocarbons, ene for double bonded, and ine for triple bonded hydrocarbons. And basically this is it. This is it in this molecule. It is named pentane. So this molecule is named pentane. 1, 2, 3, 4, 5. So the last example was easy and simple, but not all of organic molecules are just a chain with single bonded carbons, and it contains, an open chain like this. No, sometimes it's branched like this one. So how do we name this molecule? Of course, we cannot use the previous method. We say 1, 2, 3, 4 bute, and this is single bonded hydrocarbon, so it's butane. What about this group? This group is called methyl. Methyl because it contains 1 carbon. There's 1 carbon here attached to 3 hydrogens, as we know. So this is a methyl group attached to this carbon. So the first thing you do is to determine which is the longest chain of carbon. Of course, this is the longest chain of carbon because it's 1, 2, 3, 4. Now, how do we figure out where to start counting? Do we start from here, 1, 2, 3, 4, or from here, 1, 2, 3, 4? Scientists, IUPAC has this rule that you start counting from the side that has the chance of the occurring sooner. So the methyl group occurs sooner when you decide to count from this way. 1, 2, 2 methyl, 1, 2, 3, 4. Whereas if you try to count from here, 1, 2, 3, 4, methyl happens on the carbon 3, which is not ideal. So we count from here. 1, 2, 3, 4. So this is a 4 carbon hydrocarbon, so it's bute. And it is single bonded, so it's ane. And the methyl group occurs on the second carbon, so it is 2 methyl. So the name of this molecule is 2-methyl butane. Now let us look at another example. This hydrocarbon has 2 groups. Here we have a methyl group, which is a carbon attached to 3 hydrogens, 1 carbon, so it's methyl. And we have here ethyl group, which is 2 carbons. That's why it's called ethyl. So we have methyl and ethyl groups. The longest chain is this horizontal chain. So we mark this long chain here. And we start counting from the point that the group occurs sooner. So we start from here, 1, 2. The methyl occurs on 2. Whereas if we start from here, 1, 2, 3, the ethyl occurs on the 3rd. So this is sooner. So 1, 2, 3, 4, 5, 6, 7. So we have 7 hydrocarbon. So this is hept. And it is single bonded. So we have ane. Notice that I didn't dive into the ene and ine yet because this is, we will talk about this extensively in the course, but this is more appropriate to start with now because we try to establish these facts first. So, methyl or ethyl, which one we write first? Do we write the methyl or the ethyl first? The IUPAC has decided that you have to start alphabetically. So the ethyl is before the methyl because the E is before the M, and just for that, no other reason. And remember, as I said earlier, that doesn't have anything to do with the nature of this molecule. It's just a nomenclature that has been agreed upon between scientists. So 5-ethyl, okay, 5-ethyl, 2-methyl, heptane. Notice the dashes here. 5-ethyl, 2-ethyl, methyl heptane. Okay, so this hydrocarbon, this molecule is named 5-ethyl 2-methyl heptane.